on the recording and then share screen. So first, let's start use the whiteboard. So yesterday, I remember we started discussion about linked list, and I needed to admit, okay. And for the linked list, hold on, okay. For linked list, and if you recall the building, basic building unit is a node. So just a quick recall, okay. And a node, there are two parts. The information part and a arrow part, we call it next. And generally speaking, information part, the type is T. And the next part, the type is a node. And then for linked list, then it's a collection of nodes connected together. And generally speaking, for linked list, we just need to know the first node of the linked list. And once you know the first node of the linked list, basically you know all of your nodes in the linked list. And the last node you need to use to identify who is the last node is its next is a null value. So that's a general concept that we learned last class. And also I remember last class we also started to discussing about linked list, the constructor. So the purpose for the constructor to create an empty list. So create an empty list. And an empty list basically is just you set the first node to a null value. It doesn't point to anywhere. And then another operation that we generally use is empty, okay? And we also start discussing about insert, is it? And for linked list, the nice thing for it is it can insert anywhere, and it's quite efficient to do insert. And we also discuss the scenario compared with like if you want to insert something to an array, that it involves a lot of shifting. But for a linked list, there is no shifting. And we discussed 3 scenarios for insert. Is it when, so case 1 is you just an empty one, create an empty list, and you do insert. Is it? And the second case is insert at the beginning. So insert at beginning. And the third case that we discussed is insert in middle or at the very end. Okay, and different scenario how to deal with it. So conceptually, we discussed last class. And for linked list, there is other important operation is delete. So how do we delete some item from the linked list? And the other operation that's very important is traversing. So we call it traverse. And last class, we discussed traverse. The traverse is start from specify node, and then you do node by node visit, okay? Like the toString function basically can be implemented with traverse concept. And last class, we discussed the idea of how to do traversing and how to do insert, is it? And we haven't discussed the other important operation about a delete operation. And for delete, it's similar. So you need to consider different scenario. So let's just think about. So here we assume this linked list is already here. Is it? It's 100, 200, 300, and 400 something. Is it? And this is the first node. Is it first node? So suppose you delete, if you want to delete the first node, this is the thing you want to delete, the first node. How do we do that? Is it, so the case one is delete at beginning. Okay, then just think about how do we get rid of this? Is it, so the way to do it is then you need to reset your first, is it, to the next node. And in Java, basically there is no way you completely like erase the node. You can only reset the first node, and the allocated memory in heap is still there. Okay. So you can only reset the first node. So how do we reset the first node? Then the case is you just set first equals to what? Equals to first next. Is it equals first next? So this will take care of you erase at the very beginning. So the item you wanted to erase, you found that it is at the very beginning. So then you need to reset the first node. Okay, and let's take a look if it take care of the single node case. And so this is a linked list, but this linked list has only a single node. So single node list. The single node list, and you have first. Is it? And you said, okay, I said first equals to first, last, next, then it's set to null. Is it? So it still works. Is it? And then after you erase this, and it's going to be an empty list. So this case still works. Okay. And then let's take a look at some other cases. So we have the linked list. Suppose here we have 100, then 200, 300, 400, and 500. That's it. And this time, suppose you want to delete 300. So how do we do that? And the first scenario, or the first thing you needed to do is you needed to find the 300. Is it where it is? Is it? And you need to locate it. And how do we locate it? Last class, we discussed the concept is you need to do traversing, is it? And the way to do the traversing is you use some temporary node variable, is it? We call it a cursor, is it? So basically here, cursor is a node. The type is a node, is it? But where are you going to let it start? You let it start at the first node, is it? You let it start at the first node. And then you're going to keep moving the cursor, is it? Until you find 300, is it? So how do we do that? So then you can use some loop, is it? So the loop to do is your cursor, you want to check if it's, because how you can compare is you need to use its information part, is it? So if its information part is not that 300 you want to find, is it? Then you need to keep updating the cursor, is it? How do we do the traversing is you do cursor equals cursors next, is it? So you can see in linked list, we never did a plus plus for the loop, is it? All we did, so for the regular loop, what we did is plus plus, is it? And over here is corresponding to the concept of plus plus. Generally speaking is you do cursor equals cursors next, so that you advance your cursor. So this concept, we call it you advance the cursor. Here, the cursor concept basically is just a loop variable, okay? You can think about it as a loop variable, okay? Okay, and then you can locate it, is it? So, okay, I locate it. So cursor is here. Okay, cursor, how do I remove it? Is it the question, how do you remove 300? Is it? So visually, you can see if you want to remove 300, then the way to do it, you need to reconnect the previous one to the one after 300. Is it? Then this guy is gone. Is it? You just let the node ahead of 300 and set its arrow point to the node that after 300. And then your linked list, once it reach 200 and if it want to move to the next, it's going to go to 400, it won't go to 300. Is it? But the question is, how do you keep track of 200? Is it? So here we need another concept. We call it a precursor. So you need to borrow another node variable called a precursor. Oh. So over here, then you can define, so before your loop, is it? So it's kind of messy here. Let me erase everything and redraw it. Okay, so here, let me redraw it. So that's compare with our whiteboard in classroom. It's not big enough here, okay. So I have 100, 200, and 300, 400, and 500, is it? And here we have our cursor. We located here, is it? And always remember cursor start. So start at first, okay. Then it involves traverse to 300. Is it? How do we traverse? Is cursor equals cursors next. That's we call it. You advance it. Is it? You advance the cursor to the next. Okay. But like I said, how do you then, because what you care about is you need to reconnect 200's arrow to 400, is it? Then you can remove the 300, is it? But the question, how do I keep track of 200? Because when you do your traversing, you only advance. You only traverse the cursor, is it? There is no such thing, keep track of the node ahead of it, is it? So the idea is we can have another variable. We call it a precursor. Okay, precursor. And the precursor then serves kind of like a pair as cursor, but it's always the node, point to the node ahead of cursor. Okay, ahead of cursor. So we have our while loop. Is it? We have our while loop. The loop over here, we said, okay, we need to check the information is not the 300, is it? Okay, and then outside is you set your cursor equals to first, is it? First. And we also needed to keep track of that precursor, is it? A precursor. So the precursor use type is also a node typer. Is a node type, okay? And over here, then what you need to keep track is the precursor. You let it within the loop. Keep track of the previous position where cursor is at. And then you update your cursor. Cursor is next. Is it? Then just think about its pair move. Is it? So next cursor move to 300 and precursor, first precursor move to where cursor point. Is it? And then cursor updated to 300. If you keep doing like this, is it? And then cursor can move to 400 and precursor can move to 300. Is it? So This kind of thing, we call it a pair advance. Is it? So you can move a pair of nodes together, is it, a cursor together. And then the precursor will always keep track of the location where cursor landed before, is it? And after you find where the 300 is, then now we can solve the problem, is it? How do we let 200 point to 400? Then it's that precursors next equals to what? Equals to cursors next. Is it? Then in this case, you see, you get your 200 point to 400. Is it? So then you take care of, you get rid of 300. Is it? So this is how you remove an item in the middle of the linked list, okay, in the middle of the linked list. And like last class we discussed, when we do insert, that insert in the middle can also take care of insert at the very end, is it? Very end. So let's see if this will also take care of the case. So suppose the cursor is here. It is the last node you're going to remove, is it? And here is a precursor, is it? Precursor. So what you're going to do is you let the precursors next point to cursors next, is it? So cursors next is what? Is a null. And then precursors next, so in this case, is a null, is it? So it does take care of the case also, is it? So the code itself over here, it take care of both scenario, okay? Take care of, you can erase in the middle, you can also erase the last node, okay? Both cases is take care of. And, but sometimes when you want to search some item in the list, that item may not be in the list. Suppose you want to search 900, is it? The 900 is not here, is it? It's not in the list. And so if you just use this while loop, that won't work, is it? 900, is it? How do you stop, is it? So then the case is when cursor is not a null node, is it? Is not a null value, and then you put and the cursor information is not a null 100. And generally speaking, when you have both of this condition, okay, generally speaking, you put this null at the left side of those and operator, okay, and this kind of, we call it a short circuit. Because what it did is it first check. If it's already null, then it won't need to check if it's 900. Is it in this case, okay, you move to the last node, it's already reached beyond the last node, then why do you still need to bother its data info? As it doesn't exist. So then the loop will be terminated, okay? So generally speaking, when you have multiple conditions, especially for and, is it? Then you put whichever be the first determinant, then you put it at the listed as a very first condition. And we call this kind of condition, combined condition build, we call short circuit way, okay? Okay, so that's all of the general concept about linked list. And why I said linked way is useful is if you think about like previously, we also said like a tree, is it? If you want to build some kind of tree structure, is it? Especially like in computer science, there is a concept called binary tree, binary search tree. And in computer science, there are all sorts of trees, is it? Then in that case, you can build some kind of special data structure, is it? Then you see, it's not just a single link, is it? and it can support multiple link. That, and then you can keep building this, then build a tree. Okay, so that's one concept here, the linked implementation. And another way, and over here, what we just discussed of this concept, is it this linked way. So we start first, is it, and all the way to the end, is it? And you always let the first node point to the second node point to the third node, is it? And it's one dimension, it's a forwarding direction, is it, from first all the way to the now one, is it? This kind of linked list, it's the simplest cases, okay? We call it a simple linked list. Simple single linked list. So this is simple single linked list. Okay, it's a single linked list, and it's just one direction. Okay, one direction. And there is also, you can also implement some, we call it a two-way, okay, two-way direction linked list. Okay, so what that concept is, then that concept, you also have a tail nodes. Is it the tail nodes point, it's next going to point to the now, is it? But with that case is, it has another field for each node. Okay, it also has a one point to the previous node. Okay, it can also point to the previous node. Okay. And then for the very first one, its other part pointed to now, is it? So in this case, it's, so the official name, we call it a double linked list. Is it? So you linked not just forward, it's also backward. So from your current node, you can also track who is the previous node in this case. So it's not just next, it also has a field called previous. Is it previous field? Okay, so in that case, it's called doubly linked list. Okay, doubly linked list. Okay, so that's the concept of doubly linked list. There is also a linked list you can also do is something like this. So linked list. But the last node is not going to point to a now. It point back to the first node. Point back to the first node. So this kind of implementation, then it's called a circular linked list. Is it? Because it's not a linear way. It's a circular linked. Okay, so it's, there is no, so the last node not point to the now. What it point to the first node, but you still have something to identify where you're going to start. Okay, but it's circular. Okay, it's, there is no pointed to. Okay, so in this case, a circular linked list. So we can see there are all sorts of ways, okay, and conceptually, like for stack, as there we learned the stack. So once we learn stack, basically you can see you can also implement a stack as a linked list. So you can also use a linked way to implement a stack. So linked way to implement a stack. Implement stack, is it? And same thing for queue. You can also use a linked way to implement a queue. Okay, so here just to give us some idea how to do so the linked list, some other some other applications. Okay, And next, we can go to our code about linked list. And the linked list, I mentioned that the basic building unit, the basic building component is a node, okay? It's a node. Okay, and over here, we are going to discuss, it's all generic. Because we already learned generics, is it? So we are going to implement our linked list as a generic implementation. So then when we define this node, we define it as a generic, okay? But if you take another look over here, we define our node as a private, okay? And it's also a static class. And we need to take the look of the whole picture. Okay, let me maybe doing this so that we can take a look the whole picture of this class. Still cannot see here. Okay, if you take another close look, you will find over here I define my linked list. Okay. Here I define my linked list. And this linked list is a generic one, is it? But this generic is a bounded one. Okay, it's a bounded generic because it extends from the comparable. Okay, so the T itself must implement comparable interface. Okay, so previously we discussed this concept. And for this linked list, just like previously conceptually we discussed, there is only a single instance variable called first. And that single instance variable, its type is a node. It's a node. And over here, the node is defined within this linked list class itself, is it? So within a class, you define another class, is it? So previously, we also learned this concept, is it? And this concept is, so basically this node is what? Is an inner class. So the node over here, we implement it as a inner class, and it's a static one, okay? And it's a static inner class, and it's a private, okay? So only this linked list class itself can access this node, okay? That's what the private means. And why we use a static nested class is because with a static nested class, then you can instantiate the node itself without instantiate a linked list, okay? So that's why here we use static. And then next, let's take a look at this implementation of this linked list. And for the constructor, it's pretty straightforward, is it? We just want to create an empty linked list. And to create an empty linked list, you just set what? Set the first node to a null, okay? So this is straightforward. And empty function, it's the same thing. You just check if your first node is a null value. So not too much. And then let's take a look at the traversing, okay? So over here, basically this toString, what we try to show is the traversing. That because we are going to do node by node visit. And previously, like for stack or queue, then whenever you do loop, you loop through an array. And here the linked list, it's linked implemented. There is no array, is it? So we need to do traversing, node by node visit, is it? So how do we do it? Is you have this cursor, is it? And the cursor loop variable, the type is what? Is a node, okay? So be careful, the type is a node. And you let it start at the very first node, okay, and loop it all the way to the what? So all the way to the end of the list. How do you identify the end of the list? Just remember, you need to make the last node's next point to no, okay? And versus the general, when we do loop, it's I++. Here you do what? You do cursor equals to cursor's next. Okay, so that's how we, over here, the concept is then you advance the cursor to next node. Is it? You advance it to the next node. And then you can get its information part, is it over here, because we are going to output the contents of the linked list. So you can get the node's information, and we call it data here, okay, and add a comma, okay, so that's what we wanted to be output. And then after you finish it, you just convert everything to string. So nothing new here. So basically this toString demonstrates the traversing concept, okay. And then next, let's take a look, the insert, okay. And conceptually, we already explained the insert operation, is it? And for the insert operation, you are going to insert some item, is it? And here, for our rule, for our linked list, we are going to arrange our linked list in ascending order, okay? So here we are going to, so that's just our assumption, okay, in ascending order. Generally speaking, from Java's collections library, the insert is not in ascending order. Okay, so here I just try to explain this concept, the bounded class, the bounded comparable interface. Okay, just once again to show that. So we are going to try to insert a value, but always in ascending order, okay? So the first scenario is pretty simple, is it? If it's an empty list, so you need to check if it's an empty list. And if it is an empty list, definitely you need to create the new node, is it? So here you call the new node, is it? And then you insert with the item, you also specify the next part is null, is it? And you set it to the first node, and then you return, okay? So let's take a look at the node class. So our node class has two parts, is it? The information, we call it data, and the next part is a node, is it? Node. And for this class, it's quite simple. It just has a constructor. And the constructor, there are two parts, the information part and the next part, is it? Then you just assign the information to this information part and the next to the next part. So this class itself is quite simple, okay? We all understand it. And then let's take a look about the insert, okay, continue our insert method. So if it's empty, then you just create a new node, is it? And then you assign this new node to the first node. And because this is the case, so you create a new node, the item part assigned to data, is it? And its next is a null, is it? Then you assign first to this node, is it? So this is our linked list. And after this, basically, it's a single node linked list. A single node linked list. Okay, so in this case. And then let's see the second cases as what we discussed yesterday is you insert at the very beginning, is it? So in this case, that means you already have a linked list. Okay, you already have a link, suppose it's 100, 200 something. Now you have a new one, is it? So I have a new node created. So this step is always required because you're going to do insert, is it? So you always need to call new node. Is it new node? But the new node you create, who you are going to connect to, is it? So in this case, it's next. Connected to who? So here is the first, is it? So that's why when you call the new node, its next is the first, okay? It's the first, so these items, next is first. But that's not the end of the story, is it, for this function? What it does is you also need to reset first, is it, to the new node. This is our new node, is it? And then you get this new node added at the very beginning of this linked list. And the linked list now start at this new item, is it? And over here, if you take another close look, how do you know you're going to insert at the beginning, is it? So here we call the compare to function, is it a method? This compare to method comes from where? The comparable interface, is it? That interface. And why we said it's come from that? Because the item, the type is T, is it? Type is T, the generic. But it's said what? It extends the comparable, is it? Interface. So this item's class must already implement the comparable interface, is it? And because it's implement the comparable interface, that's why over here you can call the compare to, is it? And compare to with whatever, and then decide if it's less than or greater than, is it? So you see, it's quite useful for the comparable interface, okay? And that's the second case you insert at the beginning, okay? And the last case, case 3, is what we discussed. You insert in the middle or at the back, is it? So let's see, how do we do it? Then in that case, we said we need a cursor, is it? So if we compare with the linked list, and then this is 100, 200, is it? So here is your first, is it? And you will let your cursor start at the first node, is it? And then you will let it loop all the way, is it? Where it should stop. So that's why over here it says, okay, it's next, because you don't want to loop beyond the list, is it? You want to stop at the last node, is it? So here is to identify the last node, okay? So remember, this is last node. You want to stop at the last node, then you can do cursors next is null, okay? And otherwise, what you're going to do is you're going to compare, because over here we want to insert in ascending order, is it? So you're going to compare the item, is it, with the cursors next, okay? So cursors next is what? This is a node. This is a node, is it? And the node has data, is it? It's information part, is it? And then you call its information part. Its information is what? Is a T, is it? It's a generic T, but that generic T extends what? Extends comparable, is it? That's why over here you call the compare to, is it? Because you're going to insert in ascending order, is it? So here it's how you locate that item, is it? And if it is, so that means if it is greater than, so your item, so suppose in this case, is it 350, is it? If it's 350, then it's going to not to stop at 100, not to stop at 200, and not to stop at 200, but 300, is it? Over here, it's going to stop, is it? It's going to stop here. So if it's not 100, not 200, then it's going to keep advancing, okay? So here we know this concept is advancing your cursor to the next, is it? And once you find, okay, I'm going to insert after 300, is it? Then what you can do is, you see, you just let your cursors next, is it? And you're going to add this new node, is it? Add this new node. But at the same time, what this new node's next going to point to? Going to point to cursors next. Is it? In this case, this is a cursor. Is it? You're going to insert 350 here. Is it? So that's why this new node 350, its next should point to here. Is it? Should point to here. And the cursor's next, so 300 is a cursor. Is it? Cursor's next going to point to the new node. But new node's next is going to point to who? To cursor's next. Okay, so here just be careful. It's a little bit of the code itself, a little bit of complicated. Okay, so just be careful. A couple of things. One is when you read the code, you will see. Okay, so basically cursor's next is a node, and then you try to access that next node's data. Okay, and its data is anyway, it's some class. There's some instance. And then that instance has a method called compare to, okay? So that's this part. It looks a little bit of complicated. And the other part is over here when you do the new node, okay? When you do insert, be careful. Here you insert its cursors next, okay? So that's the insert operation, okay? And what is the next one we discuss is you want to remove something from the list. We want to remove a value from the linked list. So the first thing is if your linked list is an empty linked list, of course, there is nothing to delete, is it? So we can just throw some runtime exception, okay? Or if, like what the case said, if the node you want to delete is at the very beginning, is it? So this is the node, is it? And its information part. And then that instance has a method called equal, is it? Try to see if you can find. Okay, if you find it, then you just reset first to first is next, is it? So that's this case we just discussed. So 100, 200, is it? So here is the item you find, you want to remove, is it? Then definitely you need to reset first to first is next, okay? So that's also straightforward. And the little bit of complicated case is you're going to insert at you're going to remove in the middle or at the very last node, is it? That's a little bit of comprehensive. Then in that case, like I previously explained, you need a pair of cursor. Okay, we are going to do pair advancing. Okay, pair advancing. So that's why at the beginning you set a cursor to first. Is that so? That's so you have 100, 200, something like. So you set a cursor to first. To the first, is it? And we also have another, we call it previous, is it previous? And at this point, just a null, is it? It's point to a null. Okay, and then you're going to start to advance, is it? And advance, I said this is a short circuit condition, that you have end condition. So you put the null first, because once you reach null, you don't care about the remaining, is it? So that's why over here you put null first. And then you're going to see if you can find the item, is it? So if it is not the item, then what you're going to do, you're going to set the previous to cursor, and then cursor to cursors next, is it? And then you can keep doing. So the next pair advancing is precursor move to 200, cursor move to 300, is it? And so be careful about the order of these two, okay? You cannot swap. Don't swap those two. If you swap those two, then precursor will not be ahead of cursor, okay? Because you need to first set, let the cursor point to, so pre is here, is it? And then you move your cursor to the next, okay? You let your precursor remember your current location, and then you advance yourself to the next location, okay? So when you do pair advancing, always keep this in mind. Okay, and then in this case, you can find the item you want to remove, is it? And after you remove, and if it's already reached the end of the list, that means item not in the list. Is it? So you cannot do delete because it's not in the list, is it? So you just throw exception. Otherwise, what you do? You just delete the item. How do we delete? You just set the precursors next equals cursors next, is it? So that's the case is, so here is suppose a precursor, is it? And here is a cursor. So you want to delete this item, is it? So precursors next equals to cursors next, is it? So then this item is going to be gone, going to be removed, okay? So that's the idea here. So that's about the remove method. So basically, this class, linked list class, now we understand, okay? So next, let's take a look the driver part. So for this driver part, what we did first is we are going to create a string linked list, okay? And we first check if it is empty, okay? Then I'm going to try to insert some string, okay? And then I'm going to print, is it going to call the toString function over here. I call the toString function. And then after that, I insert again, is it? And I call the toString function. Then I call remove function, is it? Then I call the toString function again. Okay, so that's this part. And then we create an integer linked list because the linked list we create is a generic one, is it? So now I create an integer linked list. Then same thing, is it? I do insert. But this linked list, as we explained, it's a what? It's going to be arranged in ascending order, is it? When we run, you will see, is it? So then you call the toString, that basically it's a traversing, okay, node by node. And then you can insert some more item and remove more item, okay? So the driver part is pretty straightforward. So let's take a look at the running result. The running result, if you take a look, yeah, you see the created string list, it does arrange in ascending order, is it? And whenever you insert a new item, it's going to be inserted where it's supposed to be inserted, is it? And then you remove E, is it? After you remove E, did you see it's still linked way implemented, is it? And then same thing for the integer linked list, is it? We create one and we insert a new item and then we remove the item, okay? So it does did what we implemented. So today, basically, we know how the linked list is implemented in coding, okay? And do you have any questions? If you don't have any question, and how about you just send to the chat your name, okay? So let's just keep track of the attendance. And you can, I will also give you some bonus point. Oh, I have one question. Oh, okay, no question, it's just the. And also, I think next Thursday, you're going to have the exam. Okay, so make sure, don't forget about the exam. So then I'm going to see you all next week. Bye.